here is another composite domain example. Again, we have f of x equal to 1 over, not again, we have f of x equal to 1 over x minus 1. We have g of x equal to the square root of x minus 5. And we know the domains of these. Here, x is not allowed to equal 1. Here, again, like in the previous example, x is greater than or equal to 5. So the thing is, it's interesting is when you compose these, you're going to get something completely different. So if you look at f of g of x, which is f of the square root of x minus 5, which is, so f is 1 over x minus 1, so f of something else is 1 over that something else minus 1. Alright. Sorry, that's probably not quite big enough. I'll draw it a little bit. So that's 1 over the square root of x minus 5 minus 1. So we know for sure x has to be bigger than or equal to 5. Because again, you have to obey the domain of the inner function. But we also know that the denominator can't be 0. So we need the square root of x minus 5 minus 1 equal to 0. Whatever the solutions are to that, we have to get rid of those answers. So adding 1 to both sides, squaring both sides, so you get x minus 5 equal to 1 squared, which is 1. So x equals 6. So we also want to get rid of 6. So combining both of these together, we've got 5 here and 6 here. We want everything bigger than or equal to 5, but we don't want 6. So our domain would be everything from 5 to 6, union 6 to infinity. This makes sense if we look back at the original composition here. Clearly x can't be anything smaller than 5. If x was 4, you'd have the square root of a negative number. Or if x was 3, you'd have the square root of a negative number. And x can't be 6, because if x was 6, this would be 1, and 1 minus 1 would be a 0 in the denominator. So everything besides numbers less than 5 and besides 6 is in our domain. Alright, let's look at the reverse direction of composition. So let's look at g of f of x, which is going to be a little bit complicated. It's going to be, g of f of x is g of 1 over x minus 1, right? Because f of x was 1 over x minus 1. Yeah. And then that's going to be the square root of not x minus 5, but our stuff. 1 over x minus 1 minus 5. And here we have to be extra careful. So we know for sure that x can't equal 1, right? It's not in the domain of the inner function. And then we also know that 1 over x minus 1 minus 5 has to be greater than or equal to 0. Now, when solving this, it's incorrect to add the 5 over here and then multiply both sides by x minus 1. I'm going to write it down, but then I'm going to erase it, so don't write this down. So if I did this, and then multiply both sides by x minus 1, I'm making a mistake. And the mistake that I'm making is that I don't know if x minus 1 is positive or negative. If I multiply by a number that's negative, I have to change the order of the inequality. So I'd actually have to split this up into 2 cases where x is bigger than 1, less than 1. It's just a whole mess. It's much more straightforward to leave everything on one side and get a common denominator. So I'm going to rewrite this as 1 over x minus 1 minus 5 times x minus 1 over x minus 1. If you like, you can write this as 5 over 1 times x minus 1 over x minus 1 greater than or equal to 0. And then I'm going to rewrite this as 1 minus 5 times x minus 1 over x minus 1, whoops, x minus 1 greater than or equal to 0, which is then going to become, so I'm going to distribute the minus 5 and get 1 minus 5x minus 5 times minus 1 is plus 5 over x minus 1 greater than or equal to 0. And so finally, on top I've got 6 minus 5x over x minus 1 greater than or equal to 0. So now I need to include the zeros and the undefined points. So where is this undefined? At x equals 1. Where is this equal to 0? At 6 minus 5x equal to 0, so x would equal to 6/5. So on my number line, here is 1, here is 6/5. Right? 6/5 is just a little bit bigger. How's the lighting here? Anyways, turn off the light. That might be better. Sorry about that. So if I pick a number larger than 6/5, like 10, the top is clearly negative, the bottom is clearly positive. So it's negative over here. Picking a number between 1 and 6/5 is kind of a pain, but we can do it. 1 is 5/5 or 10/10. I mean, I guess if I was smart, I would say this is 1 and this is 1.2. So pick something in here like 1.1. If you plug in 1.1, 6 minus 5 times 1.1 is 5.5. So 6 minus 5.5 is positive. 1.1 minus 1 is positive, so it is positive in here. And then finally pick something over here like 0. The top is positive, the bottom is negative. So we want the parts where it's greater than or equal to 0. I'm going to erase this 1.1 right here. So we want the positive parts. And do I want the endpoints? Well, it's kind of a trick question, because I do want the endpoints that make it equal to 0, which is 6/5, not 1. We already knew we didn't want 1, but we also see here, 1 would make it undefined, so we don't include 1. So our domain for this function is very, very small. It's everything from 1 exclusive to 6/5 or 1.2 inclusive. All right, and that is the end of that example.